process in which a substance is dissolved by another substance without chemical change. There are two parts to every solution, one component being a solvent. In this case, water. The solvent is the one that dissolves the solute. In this case, sugar. The solute is the one that's being dissolved. Science.
There are 4 different ways to increase the solubility of a solution. The first one is heat.
Another way to increase solubility is to increase surface area. You can do this by grinding the solute.
A third way to increase solubility in a solution is to stir.
Fourth and final way to increase the solubility of a solution is to increase the concentration of the solvent.
To understand why like dissolves like, we must first understand what an intermolecular force is. An intermolecular force, or an IMF, is an attractive force in between molecules. Polar substances, which have higher intermolecular forces, dissolve each other, like this example with water and salt, which are both ionic compounds.
We're late for science class.
No! That's the one with the numbers, right? Dr. Jennett, how do you tell the difference between the solubility of gases and like the solubility of solids?
Well, that's a good question. So you can see on this solubility curve that compares solubility in water and temperature, that as temperature increases, the solubility of solids goes up and the solubility of gases goes down.
Science?
Science.
For our next problem, how about we have a student volunteer? Miss Hansen, would you like to join the class and do a problem on molarity?
Okay.
So, Miss Hansen, can you please explain what molarity is?
Yes, okay, so molarity is like, it measures the concentration of a solution. Yeah. And you can find it by putting the moles of the solute over the liters of the solution.
And can you give us a sample problem, please?
Yeah, sure, no problem. So, for say, we have 0.25 moles of NaOH over 1 liters. I don't know, this is a really hard problem. How am I going to figure this out? Alright, and since obviously this is a really hard problem, I'm going to need my handy dandy calculator. Shanae, please. Thank you. Alright. You're going to pull up your calculator app and type in 0.25 divided by 1. What a coincidence. It's 0.25. Alright. So my molarity equals 0.25. Did I do it right?
Yes.
Yes.
Thank you, Miss Hansen, for that wonderful example of molarity. Do we have any student volunteers to show what molality is?
Pick me, I got this.
Any student volunteers?
Pick me.
All right, Allie, you go ahead and do this. Okay, Allison, explain molality.
Molality is the mole solute over kilogram solvent. So, an example problem would be 0.26 NaOH over 2 kilograms. Calculating 0.13. Yay, Allison!
Okay, class. Colligative properties are properties that depend only on the number of solute particles and not on their identity. 2 different colligative properties are freezing point and boiling point. Shown on this heating curve of water, freezing point happens between ice and water, right here, and temperature stays constant over amount of time. In addition to freezing point, boiling point happens between water and steam, where temperature also stays constant over time. Let's do some examples. Now, class, we're going to find freezing point depression. In order to find freezing point depression, you have to use this equation, delta T equals m times K base F. Delta T is equal to the change in temperature, m is equal to molality, and K base F is equal to the freezing point constant. So from our previous equation that Allison did, we found that the molality is equal to 0.13, but since it's an ionic compound and it breaks into 2, you have to multiply that by 2. So that would be 0.26. And since K base F is a constant, we know that it's equal to 1.86. So, after multiplying these two together, you find that the change in temperature is equal to 0.48 degrees Celsius. Now we're going to calculate boiling point elevation. It's very similar to freezing point depression, where delta T is still equal to the change in temperature and m is still equal to molality, but we use K base B instead. So we can use the same molality from the last problem, which was 0.26, and we're going to multiply that by K base B of water, which is 0.512. Multiplying those together, we get 0.13 degrees Celsius as the change in temperature. Alright class, see you tomorrow.